Here's the ladder of tones. It starts at 8 kHz and climbs to 20. Somewhere up there you probably stopped hearing them. I can't tell you where, and neither can this video. Because it could either be your ears, it could be your headphones, your speakers, the room you're in, or what the platform did to this file on the way to you. The whole point of what follows is that you can't tell which. And the one number everybody quotes about hearing and age is real. It only holds for people not exposed to high noise levels in everyday life. And that's the part that gets left behind. So I went and found the page it actually comes from. And the caption under the graph changes what that graph actually means. The top of human hearing gets published as 20 kHz. The measurement is 16 to 18. And it's measured on listeners aged 20 to 25 with no prior noise damage. So that figure belongs to them under those conditions, and it got handed to you. Here's a smaller one that shows you the same habit. The threshold of hearing at a kilohertz gets drawn as 0 decibels. The measured value is 3. So 0 is the round number that got chosen for the chart. 3 decibels is what 100 normal hearing listeners gave on the 50% curve. So it's a tiny difference, and it doesn't matter to your mix at all. It tells you what kind of number you're looking at. The tidy one is the one that traveled. This is the curve. By 60, the quietest 10 kHz tone you can hear has moved up to about 30 decibels. At 40, it has moved about half as far. And I'm not going to argue with it. It's a real measurement, and it's in a textbook that is careful about its conditions. So let's actually read the condition. The subjects were people not exposed to high noise levels in everyday life. That then makes the curve a best case. It's what getting older looks like if nothing loud ever happened to you. So anybody who spent time in front of a PA, like myself, or on a motorbike, or mixing loud for years, like I've also done, sits somewhere the published curve was never describing. The number survived the trip, the sentence underneath it didn't. And there's another book here that puts the top of hearing in old age at 12 kHz for women and 5 for men. It doesn't say who it measured or how or under what conditions. 2 textbooks, 2 pictures, and only one of them shows it's working. Okay, so what does the top end actually buy you? Hearing gets described as 24 critical bands, and they're tabulated with real edges. The last 2 of those 24 cover everything from 9.5 kHz upward. 2 bands out of 24. There's a second table that converts bands into how many separate pitches you can tell apart. The whole scale comes to about 640 steps, and one band is worth about 27 of them. So the entire region this test is asking about is somewhere around 50 steps out of 640. That isn't nothing, and it also isn't a quarter of your hearing, which is what losing the top octaves sounds like when you say it out loud. The parts of a mix I make decision about sit a long way below there. One more thing about the tone these videos use. 17 kHz sits above the top of that tabulated scale, which stops at a 15.5. Now, the part that makes all of this shakier than it looks. This video is not reaching you the way it left me. Someone uploaded a known sweep to YouTube and then downloaded the actual files it hands out, rather than recording the playback. In that test, the AAC version stopped at about 16 kHz, and the Opus version went to about 20. So exact same upload, same video, 2 different files depending on what you were watching on. And only one of them still had a 17 kHz tone in it. And that was one upload on one platform, so I can't promise it's what yours does today. It does show the delivery chain gets a vote. So, can you hear this? Has an unstated condition sitting in front of it, which is, did it survive the trip? And there's just no published bitrate table that says a codec cuts at a given frequency. Opus pick its own bandwidth from the bitrate unless you force it. The specification says it never codes above 20 kHz, and that's a ceiling, not a promise. I tried to measure my own last upload and there's no hard cliff in it. Energy is still there at 18 to 19 kHz, falling smoothly. And I can't tell you what that actually proves, which is the honest answer. I don't know whether the codec kept my top end or whether my top end was quiet to begin with. A spectrum on its own can't separate those two, and I haven't run the test that would. Okay, so I ran it. I took the finished file from my last video, downloaded what YouTube actually hands out for it, and put the two side by side. The file my laptop gets still has everything up to 20 kHz in it. That's the one I'd measured. The file a lot of phones get stops dead at 16. Again, same upload, same video, same second of audio. 17 kHz is either sitting there untouched or it's 55 decibels down, which is gone. And which one you get is not something you choose. So it wasn't that my top end was quiet, it was there. One of the two files just doesn't carry it. That's my video, measured today, and it's one video on one platform, so read it as an example and not as a rule. One last thing, and that's actually the reason that I made this video. That if you're over 25 line. I went looking for where that number actually comes from. The trail runs back to a device sold to move teenagers away from shop fronts. The maker's own pages put its youth tone somewhere between 16 and 18.5 kHz, with a separate 8 kHz setting for everybody. In 2006, kids turned that sound into a ringtone that teachers couldn't hear. By 2009, it was a web page asking whether you hear like a teenager, telling you that if you don't, you're probably over 25. That's the earliest version that I could find, a blog post, not an audiogram, not a study, not a clinic. I can't prove it's where every later copy came from, and I don't necessarily need to. And the paper people cite for that device's frequency and level says plainly that it never measured one. The unit was too expensive to buy, so the numbers came from the manufacturer. I also went looking for anybody who would check whether these clips agree with a real hearing test. I couldn't find one. I'm not telling you nobody has ever done it, I'm telling you I looked and came back with nothing. And that a claim with nothing behind it is the thing that this channel is about. A real test happens in a booth with calibrated gear, a known level at your ear, one ear at a time, and a repeat. So don't chase what you can't hear, and don't take a figure off a chart without reading the caption underneath it. The caption is usually where the useful part was. And if you want to know what your mix does somewhere else, check it rather than guess. If you're interested, I built Check, which is a free plugin you can download on my website, totally for free, and this is exactly why I built it. Please subscribe, like, if you find any value in these videos.